Hello everyone. Today we are going to learn about types of chemical reactions. So basically if you see children, there are four types of chemical reactions. The first one is called chemical combination reaction, or we call it by the other name synthesis reaction. The second one is called chemical decomposition reaction, which is furtherly classified into three types. The first one is called thermal decomposition. So this reaction will happen when you provide the heat energy. And the next one is electrolytic decomposition, which is said to be taken place in the presence of electric current. And the third one is called photochemical decomposition or photolytic decomposition, which takes place in the presence of light. So the major source generally we take is a sunlight. And third one is called chemical displacement reaction, or we call it by the name single displacement reaction. And the last one is called chemical double decomposition reaction, or we call it by the other name chemical double displacement reaction. So these are the major four types of chemical reactions, children. So today we are going to learn all these four types of chemical reactions in details by the suitable examples. Let's go ahead with the first one, chemical combination. So a chemical combination, as I said you, it is also called as synthesis reaction. So in this reaction, basically a reaction in which two or more reactants combine to form a single product. So this is the most important, children. So we are going to focus on the word how many products are formed. A single product is formed. So we call that as a combination reaction. So you can see in a short form, A plus B gives rise to AB. So what are A and B called here, children? So we call A and B as reactants, and the new substance which is formed after the reaction, we call it by the name product. So how many products are formed here? Only one product is formed. So hence we call this reaction as a combination reaction or synthesis reaction. So you can see some of the examples which are given here. The first one, calcium oxide reacts with water, or calcium oxide is dissolved in water to form calcium hydroxide. So what are the reactants here? Calcium oxide and water are the reactants, and we get the single product which is calcium hydroxide. And the next one, calcium oxide reacts with carbon dioxide to form calcium carbonate. Even here also you can see only one product is formed. The third example, sulfur trioxide dissolves in water to form sulfuric acid. So even here we see the single product form. And the last one, sodium reacts with chlorine to form sodium chloride. So if you observe this pattern, children, here the number of reactants are two. So sometimes even the number of reactants may be more than two, but however, the products are said to be only one product. So such kind of reactions are said to be called as combination reactions or synthesis reactions. So here you can see in the RHS part. So this will be like LHS. A plus B is in the LHS part and AB is RHS. Same way here, if RHS part after the right arrow mark, if you see everywhere we could see the single products. That is CaOH taken twice. Here it is CaCO3. Here it is H2SO4. Here it is 2NaCl. In all these we see the similarity. Only one product is formed. So hence we call it as a combination reaction. And coming to the next one, we have chemical decomposition reaction. So which we call it as the opposite for the chemical combination. So why we are calling as opposite reaction means, in the previous reaction we have seen there are two reactants but only one product. But here in this reaction, if you see, there is one reactant but the products may be more than one. So like example here, the generalized equation, if you see, AB gives rise to A plus B. So this decomposition, the word decompose means basically it is nothing but breaking down of substances. So this breaking down of substances may take place in three different formats. Some of the chemicals may absorb the heat to break down. Some of them we need to pass the electric current, and some of the chemicals just we need to put in the light, exposure of sunlight, so then the chemical reaction takes place. So based on this type of source of energy given, the chemical decomposition is classified into three types. The first one, with respect to heat, we call it as thermal decomposition. With respect to electric current, we call it as electrolytic decomposition. And with respect to light, so we call it as a photolytic decomposition, or we call it as photochemical decomposition. Right. Now we are going to learn in more detail about the three types of reactions under this category. Let us proceed. The first one is thermal decomposition reaction. So you can see here very clearly, AB on heating gives rise to A plus B. How many reactants are there, children? Only one reactant is there. But how many products are there? Two products are there. So such kind of reactions, the reactants will be only one, but the products may be two or even more than two. Like even you can see in this first example, there are three products, children. In the second example, we have two products. So basically, what is a thermal decomposition reaction? A chemical reaction where a single substance breaks. So that's what I was telling. Decompose means basically it is breaking down into two or more simple substances. How? With the help of heating. Directly take that chemical in a test tube or a watch glass and heat it. Direct heating will try to break that substance into two or more substances. And what is the necessity to provide that heat? So since the heat is required to break the bonds between the substance, and this reaction is hence called as endothermic reaction. So the reaction in which heat is absorbed. So because of the absorption of heat only, the substance after absorbing the heat, it is trying to break down to form two different substances. Like if you take example, lead nitrate on heating gives lead oxide, and a brown color fumes, which is nitrogen dioxide gas, is going to release, along with the another release of gas, which is a colorless gas, oxygen, is going to be produced here. So if you observe carefully, how many reactants are there here? Only one reactant is there, but the products are here. How many products are there, children? Three products are there. The three products are lead oxide, which is yellow colored substance, which is a solid in state, and the other one brown color fumes, which is nothing but nitrogen dioxide gas, and a colorless gas, which is oxygen. Similar example, if you take a small amount of calcium carbonate, which is called limestone. Take some limestone and heat it. So on heating, this limestone is going to decompose to form calcium oxide and carbon dioxide. So calcium oxide is also called as quicklime. So in this reaction, if you observe, reactants are one, but the products are two or more. So hence we call this reaction as thermal decomposition, since the heat energy is provided in these reactions. Now moving on to the next type of reaction. So in these reactions, heat energy is not sufficient to break them. So we need to pass electric current. So we need to pass the electric current. So those type of reactions, what we call here as electrolytic decomposition. So the word electrolytic decomposition has come because of the passing of electric current or electricity through the molten form of the substance. Directly the solid substance will not break down to form two or more substances here. So we need to take the molten or aqueous solution of that substance, and then this reaction is going to be complete. So if you look at the definition, when an electric current is passed through an aqueous solution of a compound, it may result in an electrolytic decomposition. So this example, if you see this, you have studied in grade 7 children. So electrolysis of water. So water is an example where we can do the electrolysis process. So what will happen children, when water molecule, by adding little bit of common salt or a dilute acid of HCl or H2SO4, if you add it and pass the electric current, so then this water molecule is going to break down to form hydrogen gas and oxygen gas. As you are aware that hydrogen gas is going to be collected near the, as hydrogen is a positively charged ion, it is going to be attract towards the negatively charged electrode, which is cathode, and oxygen gas will be collected at a anode. In the similar way, you can take some sodium chloride, the common salt which we use for cooking. So add some water and make it aqueous solution. So this aqueous solution is in the presence of electric current, it is going to dissociate to form sodium metal as well as chlorine gas. As chlorine gas is negatively charged ions, so chlorine is going to be collected towards the anode, and the metal sodium will be collected at cathode. So in this reaction, if you see children, the reactants are only one, but the products are two. Even it may be sometimes more than two also, but however, what is our focus should be on how these kind of substances are going to be break down. So this is going to break down in the presence of electric current. So that's why we call it as electrolytic decomposition. And some chemicals, no need to pass heat, no need to pass electric current through them. Just take that chemical and put it outside the container. So there we see the chemical reaction is going to take place. Here also, a single substance is going to break down to form two or more substances. Like if you look at this, AB is going to break down or dissociate to form A plus B. A photo decomposition reaction is a type of decomposition reaction in which a reactant is broken down to its constants by absorbing energy from photons. What is basically light children? Light is nothing but basically a group of photons. So when these photons fall on these chemicals like silver chloride and silver bromide, so they are going to dissociate to form a gray colored substance, silver, and which releases a gas called chlorine gas, so which is the smell of a bleaching powder. So silver chloride in the presence of sunlight gives silver and chlorine, and silver bromide in the presence of sunlight gives silver and bromine. And here the major focus will be on the color children. So they will be asking regarding the color change after the chemical reaction. So before the reaction, silver chloride is white in color, and after that it changes to gray color. As you know that silver is a shiny gray substance, whereas silver bromide is light yellow or pale yellow color, and which is furtherly going to change into gray color. And another interesting and important question they'll be asking on this, so the use of these two chemicals, where generally we use these two chemicals, silver chloride and silver bromide. So both of these chemicals are used in olden days. Nowadays we are having a digital photographs and all, so previously they used to laminate. So there we are going to use this in black and white photography. So these two chemicals are used in black and white photography. So this is all about the three types of chemical decomposition